So for this lecture, we'll talk about the RMG tools that are available. So basically, RMG has, RMG has tools, kinds of tools. One is we call it scripts. The other is IPython. IPython is the one we just used. And the scripts, you can think of the RMG.py. You try to generate a model this morning. So for scripts, it usually ends up with .py, and for IPython is end up with IPython. Usually, for the scripts, the input is pretty simple. You provide some, say, input file, or you provide the model mechanism file. But for IPython notebook, as you just worked out, it allows you to, input at multiple points, and trying to do really some really complicated stuff. Scripts usually it takes longer time, so you can just launch the script and put it somewhere and get back to check it, say 1 day later, sometime later. But for IPython notebook, usually each cell is pretty short, so you can interactively go through all the notebook. Even tell scripts really has very little user interaction, while the IPython notebook has a lot. And scripts have very little instruction. To know and to learn the instruction, you can go to the RMG website documentation to look for more detail. But IPython notebook, you can see there's instruction almost everywhere when you run a cell. I will focus on the scripts for this lecture. So to find scripts, there are basically two locations. One is within RMG-py /scripts folder. There are several. And also in the RMG database /scripts, there are also some scripts. So I don't know if people can see me on the left. For RMG-py, if you click the scripts, there's multiple .py files right here, including, say, deep models, merge models, etc. And if you go to the RMG database, there's also a scripts folder. And for this one, it kind of mix notebooks and scripts. Well, in the RMG one, you only have scripts. So to run the scripts, remember, always you need to have a activated RMG environment. So for me, for now, you can tell this RMG _in at the very beginning, which means the environment is already activated. If not, you can always run this conda activate RMG in to activate the RMG environment. The second step is usually Python, then the script path, and all the arguments, possibly the template file or some input file. To terminate the running script, you can always use Ctrl+C or Command+C. If you look for all the scripts talking about today, if you look for more detailed instruction, you can check this manuscript. Sorry, the documentation. I guess it is usually very hard to learn something without examples. And if you're looking for examples, so in the RMG-py, the same
question. When you run these ones, you said Python and then script path, not Python JL.
So that's a really good question. In the Docker file, I think we linked the Python to Python JL by default, so you can simply use Python. But when you install it on your own, you either need to manually link Python to Python JL, or you can instead run as Python JL, some script path and the arguments. Yes, thank you for adding that. Let's get back to the examples. So in the RMG-py folder, there's examples. So this morning we ran into the RMG folder. If you're looking for examples for scripts, there's also a script folder, and it shows some of the commonly used ones, namely, say, deep models, merge models, etc. here I list kind of most of the scripts commonly used in RMG. So for generate campaign HTML, so as you can imagine, campaign file, or I don't know whether you have checked out the campaign file, but basically it's a text file with tens of thousands of lines. You can definitely go into the file and search for keywords or things by text editors. But if you run this generate campaign HTML, it offers you a kind of GUI style thing to go through the campaign file. I will show an example. So in the Docker file, you can go into this generate campaign HTML folder. So I will do it in Visual Studio Code. You can do it also on your terminal. So you first do cd, go into this folder, which is RMG Pi example scripts generate campaign HTML. Then almost all of the example folders, there's a so-called .sh file or examples.sh file. It's kind of contains the syntax of the script you need to run. So I will get back to it right now, but let me first launch it. So if you want to launch the file in .sh, you can just do ./run.sh and enter. It will run the scripts or the things inside this file. And if we look into this file, what it basically do is it calls Python, actually Python JL here. And the scripts we are running is this generate campaign HTML.py, which is located in RMG Pi scripts. And then the first argument is the campaign file. Usually usually from RMG output, there will be a annotated in file, which has all the details about the data resources, the structure, etc. And there's species dictionary.txt, which indicates what's the structure for each label of species. So for this example, these files are located just beside the run.sh. Here is the campaign file. I won't go through that, but you can tell usually go through this file and search for keywords and learning something can be the process. And there's also a species dictionary file, which has the label at the beginning of and the adjacent to the list, follow the label for each of the species. And this may take a while because it also loads the Python Julia module, which the communication between Python and Julia, I don't know why, but sometimes take a while. Since I already run it, I will show you the what the output looks like. In the Visual Studio Code, you can download it. Another way you can do this is you open the Docker desktop, you click the container, then you click the RMG container. Then there's a files tab. You can look for the files. And say I feel it's slower than the Visual Studio Code somehow. Scripts, then we just generate the campaign HTML. And this is you can right click it and then save it to your local environment. And me, I will just download it and open the. One problem here is actually if you can visualize this file within the environment, you can visualize all the structures. But since I only export the HTML file alone, so it won't show the structure here, but it will definitely list all the thermal properties you care about. And this is for the species section. And for reactions, you can filter reactions by the reaction family or the reaction type. You can also search for a specific reactions in this by entering its label. For example, this should give you, if you have stage 3, 4 in the reactant or one set of product, what are the relevant reactions regarding this. You can click on these buttons, which will show you a block that you can, I guess you can potentially copy it to the RMG files or somewhere, or simply to read the coefficients and the comments. And you can also click on this campaign strings. So you can also copy this file, copy this block to a model right here about. So in short, this provides you with kind of GUI things to access the campaign file. So there's after do the generate campaign HTML file, there's a species folder. If you want to visualize all the species as well, I think you should also download this folder. You can then visualize all the molecule structures also in the reactions, which give you some more readability. This is for generate campaign HTML. Then let's go to the deep model. There's another folder called deep model that is located in the scripts. We can change directory to the deep models. As what we did, first let's run the example.sh. Or otherwise, you can also say entering into this file, you copy paste this plot and entering into the terminal. I think it will give you the same results. So for the deep models, what it does is try to compare the difference between two models. The input for the scripts means, of course, since you are comparing models, you need the mechanism files for the models. Ideally, you want to match or check if the models have the same species, so it needs to know the molecule structure in order to compare. Otherwise, if a species have different labels without supplying the dictionary files, it will treat them differently, which is not ideal. So you input the first mechanism file and its corresponding species dictionary, then you input the second mechanism file and the second dictionary. These are all located also still right here. So afterwards, as you can tell, it will generate a deep.html file. It looks pretty similar to what we just saw for the HTML campaign. It also will generate two folders. And to give you some sense of what the output looks like, let me download it to my local environment. And then I can open this deep.html file. So in this, you can easily tell there are 32 common species. For a lot of them, the thermals are just identical. But for some of them, say either their thermal are reasonably close to each other with within some tolerance. But there are definitely some thermals that are really out from each other. I guess for this example, you can tell the CP at 115 and 1500. At the beginning block of this file, it shows all the differences and lists all the numbers so that you can have a better sense what's the difference between models. Then it will let you know what are the unique species in each of the model. So you can tell model one have more speed, 4 more species than second model. And these are their results. Afterwards, you can also compare their reaction rates, rate coefficients with a similar identification. For simplicity, well, by default, it will simply show the reaction, but you can definitely show their kinetic rates as well if you want to do a more detailed comparison. And you can filter out by the reaction type as well. And again, at the very, I think at the very bottom, it will show all the unique reactions in each mechanism that doesn't match to the other model. So say if you generate a model, then you improve some of the parameters and say regenerate a model, you can definitely use this deep model tools to compare what are the things that change a lot between different models. Okay, so third thing I wanted to show is this generate reaction scripts. There's generate reaction scripts folder, and there's random sh. So what this script does is it only needs a simple input of pi, and the style of the input of pi is almost identical to the RMG input file. So here you need to assign the same database information as well as the species you want to react to, so that they can cross-match each other and react, and will generate a comprehensive list of all the possible reactions and the conditions you care about with the database you supply right here. And the output is also pretty similar to the normal RMG run. You'll get Canadian, seed, solar species. But the different thing is it will has an output on each HTML. And if you look at Canadian file, this possibly to be the thing you want to check, because it contains all the reactions that say the initial species that can cross-react with each other, and all the products they generate from those cross reactions. It will not only include all the thermal data, but also the reaction rates for each of them. So say if you have a simple example, you don't want to run the whole RMG model, you just want to check if some of them can react or not, what are the reactions, and what's the RMG estimation, you can definitely run this without wait for several days of RMG runs. And then I want to introduce merge model. So we go into the merge model. Just as the deep model, merge model kind of requires you to input 2 different models, and instead of compare their differences, merge model kind of try to combine them together. So if there's common reactions or common species, the order does matter. So if we look into the scripts, the script is called merge models. You input model 1 and model 2. If there's anything that are in common, say a common species or a common reaction, you will always use the parameters from the first model instead of the second model. This is really useful. Say sometimes if you are studying a mixture system, there have each one of them can react to a set of different intermediates and products. Generating, say, including all the mixture components in a single RMG.py is doable. However, it can be time-consuming because it will try to find all the cross reactions and expand like in a logarithm style, in terms of the model size. So alternatively, you possibly can do is you just give the single component of the mixture and make RMG mechanism for each of the single component. Afterward, you can merge models together. However, there's a problem with that because if you include all those components in a single input file and run a single RMG job, you will generate a cross reaction. However, if you run them separately and then merge it, you will lose the cross reaction. So I usually suggest once you merge the models, you use the merge model as a seed mechanism and run another RMG iteration so that RMG can try to figure out the cross reaction. There's also thermal estimator in this block. So what thermal estimator does is thermal estimator take an input of pi and you look for all the thermochemistry data for the species that listed in this input of pi. For example, in this input of pi, it lists several different species. So 1, 2, 3, 4, 5. And after you run the scripts, it will generate chem annotated file and with all the things. This can be useful, say, if you don't really want to use RMG, you just want to search for chemking, say the thermochemistry for several species. However, manually check all of the species on the RMG website can be frustrating. So you can simply input the files in the input file here and run the thermal estimator script, and we will return all the information you need as output. There are others. Potentially, you may want to use the import chemking library, which basically import a chemking file into RMG database as a library. Say if someone published some really good data and compose that into a chemking file, you can potentially do that with the import chemking library. However, in order to do that, you need a species dictionary, which for now is the most difficult thing to compose. If you are lucky, some people will give you some like glossary or some files you can refer to, so that you can. We have some scripts to convert all the, say, if they have a list with labels and their corresponding entry or smells, you can then easily convert it to a species dictionary and then import into RMG database. And then in later RMG run jobs, you can use the library without any trouble. Many times they don't really have a good glossary, or if they have a glossary, there's some bugs or some duplicates or some mistakes in general. And usually it requires people's involvement and troubleshooting. If anyone is interested in that, we probably in the future can offer you a more tailored Python notebook instead of a script, so that you can run it by running the Python notebook and help you figure out all the issues with the chemking file that people publish, and then you can easily import it into RMG database. As for time consideration, I won't touch on Python notebook today. And for other scripts, say generate plus diagram is already incorporated in the RMS simulation file we just did. And RMS version is a bit more colorful, and you can easily tweak it within your Python notebook. And simulate, we used to run sensitivity analysis with this simulate scripts. However, RMS now have more advanced sensitivity algorithms. So, for example, the adjoint sensitivity algorithm, which greatly accelerate the calculation. And at the moment, we recommend switching from using the simulate script to using RMS, and you will learn more in the RMS section. To conclude, one more thing. Many of the scripts here are also available on RMG website. If you log into RMG website, there's called other RMG tools. You click that. There's something like visualize campaign file, which is the general campaign HTML, model comparison, which is basically the heat models. And this is provides you with a GUI style, so you don't have to work on like scripts if you are more comfortable doing something here, like in a GUI. So in short, there are majorly 3 types of tools. So you can use RMG tools on RMG website. If you are really uncomfortable with running command line, I highly recommend you doing this way. However, there's some limited resources. We can only afford 5 minutes task. So if, say, merging 2 campaign files takes more than 5 minutes, the job will never succeed. And you have still get back to running everything in the command line with scripts. And for scripts, it doesn't really require you to provide complicated input. So usually an input file or the campaign file or species dictionary is usually enough. And you can basically run whatever it is here in the RMG website. And you can also try a Python notebook. However, this requires you to have some background in Python coding and also knowing some RMG APIs. It can be hard for novice RMG users, but it's inevitable for RMG users to get, gradually switch to using a Python notebook that is more powerful and more tailored to your need. So this is just a short review of all the RMG tools. We have a more comprehensive version of this introduction in the 2021 RMG workshop. If you are willing to know others, including our Python notebooks, you can watch the other video. And feel free to try out all the tools and let me know if you have questions.